Hi, and welcome to our 70-second test and measurement video. Today we are continuing our demonstration of the Tektronix RSA306B PC-based spectrum analyzer. This recent Tektronix offering makes available many advanced spectrum analyzer features at a price that is affordable, given the fact that most users possess or have access to a PC. The key ingredient in this mix is the SignalView PC software. It comes in a flash drive along with the instrument, ready to install on your PC. Alternatively, you can download it and the RSA306B user manual free of charge from the Tektronix website. Incidentally, users have asked when and if there will be a SignalView Mac. Tektronix engineers have successfully operated SignalView PC on a Mac platform using the Apple-supplied Boot Camp application. That's where it stands at present. After the SignalView PC software has been installed in the PC, the RSA306B spectrum analyzer, the RTSA V3 demo board, and the PC can be cabled together. For this purpose, Tektronix supplies a Y-type USB 3.0 cable. The double end plugs into two USB slots in the PC, and the single end plugs into the demo board. This cable powers the demo board but carries no data. Then a standard BNC cable is run from an RF adapter at the module to the demo board, where it can be attached to any one of 7 outputs. This cable carries data, but no power. Finally, a USB cable is run from the module to the PC. This cable carries power and data. To summarize, the PC powers the demo board and the module. Neither of these has an AC cord or battery. The output of the demo board is fed into the module, which processes it, whereupon the signal is conveyed to the PC, which contains SignalView PC software, permitting the signal to be displayed in various modes and scales. Today's demonstration involves still another capability of the RSA306B PC-based spectrum analyzer, namely its ability to process a signal so as to perform trace detection and to apply function controls. To begin, we need to set up the demo board. We are using the same demo board settings as in video 71, which demonstrated power measurements with markers. With cabling in place, press the on button in the demo board. LEDs throughout light up, indicating that the demo board is prepared to output signals to the connected RSA306B spectrum analyzer and through it to the PC. Set reference to internal. Set the run mode to free run. Click the row and column buttons to select OFDM to determine the demo board output. This completes the procedure for configuring the demo board. Now we will turn to the RSA306B as displayed in the PC. Keep the same settings or recall the setting demo2_OFDM_marker.tiq. Click Run. Right-click the screen and select All Markers Off. Click the Settings button, which is the gear up above, to display the Settings control panel. In the Traces tab, select Trace 1 and then set detection to AFG VRMS, and set function to AFG VRMS also. Then select Trace 2 and set detection to plus peak, function to max hold, and enable show. Select the trace to Trace 3, select detection to minus peak, function to minimum hold, and enable show. Trace selectors process the data underlying the trace to provide the results we need depending on the current application. Available detection methods are plus peak, minus peak, average VRMS, sample, and CISPR peak. Trace functions are applied to multiple traces as they are displayed. Available settings are normal, average, maximum hold, and minimum hold. The number of traces setting displays how many traces are averaged. The same selections are available in the upper left display selection and mouse over drop-downs. The results show the 3 different traces displayed in the screen simultaneously. To acquire all 3, you may have to press Auto Test. The average trace is generated by multiple traces averaged together. There is one vertical value to each underlying frequency data point. Once the specified number of traces have been acquired and averaged to generate the displayed trace, each new trace takes the place of the oldest trace in the calculation. Max hold trace displays the maximum value in the trace record for each display point. Each new trace display point is compared to previous maximum value, and the greater value is retained for display and subsequent comparisons. Minimum hold trace displays the minimum value in the trace record for each display point. Each new trace display point is compared to the previous minimum value, and the lesser value is retained for display and subsequent comparisons. Thanks for watching. New videos are added periodically, so check back frequently.